Good evening, friends. Today we are going in more detail about the heterogeneity because in whole panel data regression model, this heterogeneity is playing a very important role. And there are many models which are used to capture this heterogeneity. So today I will go in more detail. But before going that, so let's do a summary. I just showing you the summary in the whiteboard. I hope I am perfectly audible, visible. And from today's session, we will move to the different type of heterogeneity also. So the basic term which we are discussing from last many sessions, that is the heterogeneity. Now the heterogeneity is discussed by two methods. The first method is using the dummy. And we have time dummies, we have corporate company dummies, we have individual dummies, we have interaction dummies. So everything is about the dummy. So whenever we talk about the dummies, so we have the cross section dummies, we have the time dummies, and we have the interaction dummies. So there are three type of dummies we have discussed in the session. So cross section dummies are capturing the effect of the companies. Interaction dummies is capturing the slope effect, and time dummies are capturing the time effect. But this is not very popular, time dummies, in the literature. So this is the one way to examine the heterogeneity. And we assume that the intercepts are different, the slope coefficients are different, or both are different. So, but this part of the panel data is less popular. It is very important because in you can also find out this part, but it is less popular. The reason is reason of the less popularity of this dummy part is the degree of freedom problem. So what is the degree of freedom problem? Because if we have more number of cross section units, suppose we are having 10 companies, so you can imagine that how many dummies we have to introduce. In case of 10 companies or 10 cross sections, at least 9 dummies will be included in the model, regression model. And if you want to include the interaction dummy, so the number of dummies are too much, because you have to multiply 9 dummies with all independent variables. So it is a big problem. So this is because of this limitation, the dummy heterogeneity, or studying the heterogeneity by using dummy, is less popular. Although it is very easy, but it is less popular. Now the another kind of model that is more popular, in fact, if you apply fixed effect model, knowingly or unknowingly, you are moving to the second side. So we have two, and these two models are transformation based models. The second method of analyzing the heterogeneity is based on transformation. So today I will show you that how we can transform. Otherwise, it is just impossible to understand that what is the meaning of transformation based heterogeneity. So two transformation I will show you today. Number one, within. within, and number two, between. So, and because we are using these models, these transformations to understand the heterogeneity, so we add the word effect. So within effect and between effect. Between effect. So there are two type of effects which we use: within effect and between effect. And both are the part of fixed effect model. So today, the part is to discuss within effect and between effect. So let's move to the data. Now I am showing you one simple exercise. It is a eView software, and most of the research scholars are using eViews for even panel data. One interesting thing I want to show you before moving to the example. So let's open this eViews. So it's a student version, and I am opening the data. So file open, and foreign data is work file because we have the data in Excel format. And so finding out the data which I already gave to you, panel. And so in day one, example 2, you already have this data set. So sales, advertisement, and R&D. And click next, 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 and next. So IT, sales, AD, and R&D. So this is the data. And if you just finish it, the data is coming here. And after that, we declare it is a panel data. In eViews, you have to declare that it is a panel data. To declare, go to proc, resize, and undated with ID series, or you can say undated panel. The identified series means cross-section series. Cross-section series is I. So I say I, and okay. So now it is converted into, okay. So I think the problem is there. Let me try in eViews 8. Because being the student version, if we may have problem. Now you can see that 1 to 80. So it means we are having 80 observations. And go to proc, structure, and undated panel. The cross section is I. Okay. And okay. So you can see that we are having 4 companies and 20 time period. So it is a now panel data. And let's go to the quick estimate equation. So you can see this option, panel options. Panel options. 99% of the scholar apply this method. And what is the problem in this method? Let's see. So the dependent variable is sales, and these are the independent variables. And if you want to apply the fixed effect model, you go to the panel options, and we are selecting the cross section fixed method. It is the only method available in eViews to apply fixed effect. And this is the result. So you can see that the constant is -3, Advertisement is 107. R&D is 346. Both are significant. Both are significant. And if you want to see the effects, go to view and we can see the cross-section effects. So you have four values here: 171, -10, 167, and 14. And these are the effects, right? And if you want to go to the back to the equation, click on estimate and run it. Okay. Now the problem is that most of the, in fact, not most, all scholars apply this model and don't know the meaning of this model. Why? Because if you don't understand this model, fixed effect is, you never can understand this effect. Now I'm just explaining that what is the transformation based fixed effect model. Okay, so for that I am opening the data set and will show you this result. Basically, the purpose of today's session is to show you the transformation based fixed effect model. Let me go to the data set. So Excel file is coming up. Yeah. So we are having this data. And I'm creating another variable which is constant with time. So let's say it is promoters holding. So this is a hypothetical variable. I'm just showing you that suppose you are having time invariant variable, then what happens? How the transformation will affect this variable. So for that purpose, I'm creating this variable. And let's take the, suppose it is constant for the first company. So in first company, the promoters holding is 56%. In second company, it is 67%. And in third company, it is 76% or 77%. So it remains constant with time for all the companies. So it is a time invariant variable. And it is 91%. So we have four variables. This is Y, this is X1, and this is X2, and this is X3. And let me call them, let's say I, T, this is Y, this is X1, this is X2. This is for just normal nomenclature. And it is X3. Okay. So we have these variables. Now I am going to show you the hidden or the transformation which is behind the all fixed effect models. So first of all, I am taking the mean of Y within Y, right? Then similarly, within X1, within X2 and within X3. Okay, so we have to transform these value into this. So it is quite complicated and you have to see very carefully. Or below that, before that, I can do one thing. I can break up the transformation in 4 stages. This is Y mean, X1 mean, X2 mean, and X3 mean. So just check. So I have to calculate the mean of each company. So the mean of Y of company 1 is this. This is for only company 1. So this is the mean of company 1. Copy it and paste it. So what is this? This is the mean of Y for company 1. Similarly, I can drag it to all the 3. This is the mean of X1 for company 1. This is the mean of X2 for company 1. And this is the mean of X3 for company 1. So try to understand the transformation. Because these 3 values are constant. So can I paste as values? Yeah. So what is this? This is the mean of all the variables for company 1. Similarly, I can calculate for company 2, 3, 4. So let's finish it first. So it is formula. Let's apply this formula. Copy this formula and let's paste it here. So this is the mean of company 2 from 1 to the 20. Yeah, perfectly fine. So similarly, I can copy this to this. And let's apply the formula. So it is hardly 5 minutes job. For company 3, and similarly, I'm applying for company 4. So these are the mean of all the variables for the 4 companies. So let's drag these values. Copy and just paste as value. Similarly, copy, just paste as value. And similarly, copy and paste as values. So these are known as group means. So what these numbers are? Group means. This is the value of Y for company 1. This is the mean of X1 for company 1. This is the mean of X2 for company 1, and like this. Okay, now I'm doing the transformation that every value minus its mean. So the value minus its mean. So this is called within transformation, or it is also known as de-meaned transformation. It is called de-mean transformation. So I am doing the de-mean transformation, and you just drag and drop and like bus ho gaya. So we have transformed each and every value. Now you can see one thing. If the value is constant with time, the d-mean transformation is 0. And because of this reason, if any variable is time invariant, the fixed effect model cannot take it, cannot take this value. So this is the within transformation. Now what to do with this transformation? Now I'm going to apply equation, rather regression. So let me write the equation of the regression. So how we write this transformation? We will write this transformation that y value minus group mean equal to, and so we can write like the alpha minus alpha mean plus beta 1 x minus x bar, and so let's, okay. So let me write once again. So y minus y bar equal to alpha minus alpha bar plus beta 1 x I minus x I bar 1 bar. Similarly, beta 2 x2 minus x2 bar, like that. So this is called the d-mean transformation. Now let's apply this equation. See carefully. If you go to the data, now in the data we are having this data analysis. In the data analysis, we have an option called regression, and click OK. Now here within y is my dependent variable, and all the within is my, let me check I take the right values or not. So these three are my independent variable. Let me check. So K3 to K82 is my dependent, and L3 to N82 is my independent. Fine. Do nothing, just you have to tell the software that my output, I want output here, and okay. Now the most important thing you need to observe, number one, the alpha is 0. So let's see this. So what is this value? This is value is 0, because in within transformation the alpha by default always comes 0. Let me convert them into number. And what is this value? 0. So it is a general rule. Whenever we apply within transformation, the by default alpha is always 0. And but if you say that when we apply this equation in EViews, this is not 0, it is minus 73. So it is actually a puzzle. You need to understand that. So what is the meaning of this 73? Actually, whenever we apply the regression model, the alpha is always come 0 and p values always come 1. And software also don't include this value in the equation. So you can see that it is 0, 0, 0, 0, 0. So software will not calculate any value, will not give any value of this x variable because it is constant. Okay. So this 0.107.346, if you check, so 0.107.346. So the beta are exactly same. So the beta are exactly same. Now you are asking that what is this minus 73? What is this minus 73? And frankly speaking, it is not written anywhere in the book that what is this minus 73. So let me try to explain. Okay. Now, So we have to understand that what is this minus 73. So how many companies we are having? Let's say we are having company A and B, C, D. So how many companies we are having? A, B, C, D. Okay. Now I am just taking four values. This is the Y mean, X1 mean, X2 mean, and X3 mean. So I'm just taking this four values. So let me show you that. So what I'm taking the mean. So where I have the mean? I have the mean here. This is the mean of company one. So let me take from here. So this is the mean of company 1 and 2. Copy. And where is the regression? Yeah. So we have the, so let's copy as number. This is the value of mean of Y for company A, mean of Y for company B. So similarly, we can calculate for company C and company D. So we have company C 3 and 4. So you can see that. So this is the mean of company C and company D. Okay, let's apply the formula as values. Okay, so now you may be thinking that what I'm going to do. So I am going to show you the effects, company effects. I hope up to this level we are not having any problem. Now, so you know the effects. Effects for company A and effects for company B. So let me drag and drop. So this is C, this is D. Now I am explaining you how the software is calculating the effects. So let me explain that first. Okay. So we can say the equation is Y transformed equal to alpha transformed plus beta 1 into x1 transformed plus beta 2 into x2 transformed. So these are the transformed values. Alpha is representing the transformed effect, transformed. So we can calculate that Y mean minus beta 1 x1 bar minus beta 2 x2 bar. So this is the formula of calculating the effects. So I am going to use this method. So just showing you, this is alpha. Okay. And this is the normal equation. Right. So I hope you understand the equation. It is a normal equation. It is a transformed panel equation. And I'm calculating the alpha. So I take beta 1 and beta 2 on this side. So now it becomes Y mean minus beta 1 x bar minus beta 2 x bar. So this equation I'm going to use. Okay. So the effect of A equal to, so this is the mean of Y minus, this is the beta 1. So because it is constant, so I'm putting the dollar. Multiplied by x1 bar minus beta 2, it is constant. So we put dollar and multiplied by x2. x3 because I'm not taking because it is 0. So if you multiply 0 by any number, it will become 0. So now you can see the answer is this. And let's drag and drop. So now what is the special about these effects? If you calculate the average of these, and the average will be average of all the effects will be 73. So what is this average? Average is the minus 73. So all these softwares are showing you the basically the average of all the effects. So for example, you can see that minus 73.849. So minus 849, minus 73.849. So what software is doing? Software is doing all these calculation, give you these beta and alpha, and put this average on the intercept. So there are so many things which you don't know. And now the question is that how can we calculate the actual effect? Now there are the secret of these calculation. Now I'm going to explain. The software is saying that because all the values are calculated from the software. So let's say the software is saying that the basic effect of all the 4 companies is minus 73. Or we can say this is the common effect. This is the common effect. So what is alpha? Alpha is representing the common effect. So listen carefully. What is minus 73? Minus 73 is common effect. And every company is away from this common effect. Right. So now what I'm doing, this is individual effect. And I'm subtracting. So minus common effect. Individual effect minus common effect is this. And because in this case, the common effect is common, so I'm taking it to F4. And let's say calculating for all. So you can see that minus 171, minus 10, minus 167, plus 14. Exactly these values you can see in the effects. So minus 171, minus 10, 167 and 14. So what are these? These are the individual effect. Okay. So what is the common effect? Common effect is minus 73. So let it put it yellow. And what is this? This effect is also individual effect. Now theory say that these individual effects, so the yellow part. So I'm talking about now the yellow part. The yellow part is known as individual heterogeneity, individual effect, individual effect, individual heterogeneity. This is the common heterogeneity. This is common among all. Now there are 2 school of thoughts. The first school of thought say that this much common, this much heterogeneity is common. So, and this is called random. This is the heterogeneity which is individually, which comes individually. Now, this individual effect are of 2 types. They are significantly different or they are randomly different. The concept which I am going to trying to explain you is the key concept behind random effect and fixed effect. So fixed effect is saying that this common effect is important and the individual effect may be random, may not be random. If the individual effect is random, then you should apply the random effect model. And if these 4 values are significantly different, then you have to go for fixed effect model. Now, in the next stage, the software is doing what? So we assume that the alpha I. So now you are saying that you can look at it. The alpha, uh, okay, the alpha ij, so this is intercept, is divided into two parts, right? It is divided into two parts. Number one, alpha I t plus alpha I. So this is called individual effect, and this is also, you can remove this alpha it, and because we are assuming that it is irrespective of the company, it is irrespective of the time. So it is common alpha. It is a common alpha and it is individual alpha. So these are the individual alpha and this is common alpha, right? Alpha I is different for different companies. It is called individual effect and is a common alpha. So now one thing more. The Hausman say that if you find out the covariance or correlation between the all the four companies, this is called alpha I, and the error term, right? And why we are calculating the correlation between the alpha I and the error term? Because error terms are random. Error terms are random. So this is equal to 0. So there is no correlation between the alpha and the I. So this is the null hypothesis of Hausman test. So Hausman test assumes that the individual heterogeneity of the companies and the error terms are not correlated. And if they are not correlated, listen this line carefully. If they are not correlated, it means you have to apply fixed effect model, right? Sorry, not correlated means 0. It means you can apply a random effect model. And if these individual cross sections are significantly different, they must have significant correlation with the error term. And in that case, you have to apply fixed effect model. So the selection of the fixed effect model or the random effect model depends upon whether the individual effects are correlated with the error term or not. Significant correlation means fixed effect. No correlation means random effect. So this is the basic of the within fixed effect model. So now, because I explained you the all calculations, I hope you have more clarity on the fixed effect model after this. Okay, so this is the one transformation. It is called within transformation fixed effect model. In research papers, the probability is that 90% cases you will find out the result of fixed effect model within fixed effect model. So it is so common. It is the most popular transformation in fixed effect model. The only difference is that you never understand that what is the meaning of this, what is the meaning of alpha. So like this, and I'm showing you one more thing. Suppose I go for random fact model. So now I am calculating the random fact model. In random fact model, we have Hausman test. This Hausman test will check whether the individual intercept are correlated with the error term or not. So like you can see that it is 0.47. It simply means we are accepting the hypothesis. So because p value is more than 0.05, so we are accepting the null hypothesis. It means there is no correlation between the error term and the individual effect. So what it means the individual effects are random. So if individual effects are random, it means we should not go for fixed effect model. We should go for random effect model. So within fixed effect model is working in this way. Similarly, sometimes in very rarely, however rarely, we can apply between fixed effect model. So there is another version of fixed effect model that is called between fixed effect model. So let me show you quickly that how we can apply between fixed effect model. Okay, so this is the transformation. Now I am taking what? I am taking the grand mean. So what I'm taking? Grand mean. Grand y. Grand x1. Grand x2. Grand x3. So what is grand? Grand is very easy. You just take the mean of all values irrespective of the companies. So like for example, I'm taking the average of y. This is y and complete y. I'm not taking company wise. It is the grand y, all y values. And similarly, I'm taking this. And these values are same for all the companies. So I am, oh, this part will miss. So let me make a space. Insert, shift cell down. So I think now we are having enough space. So I am copy these values and paste as value. Yeah. Now, what I'm showing you between transformation. In previous example, I show you the within. This is between. So I'm saying that it is between y, it is between x1, it is between x2, it is between x3, like that. So what we are doing, we are just taking the difference of individual group mean minus grand mean. That's it. So similarly, I can calculate for all. And now just repeat it. So if you apply the regression model between this is called between fixed effect model. So let me show you that. If you go to the data and data analysis, regression, my dependent variable is now between y, and this is my independent variable. And I want our output here. And okay. So whatever I calculated here, so you can see that all variables are significant. And this regression is called between fixed effect model, between fixed effect model. So you have two choices of fixed effect model. This is within transformation and between transformation. So these are the two type of transformations in fixed effects. 95% cases you go for within transformation. Between transformation is very rare. It is mostly applicable in agriculture, where the variables are constant with time as well as with different cross sections. So in that case, between model is applicable. Now, after showing you all these things, so I'm showing you how we can do in Stata. Because EVUs, we are having so many limitations. EViews you can do only within transformation, no, not any other transformation. And dummy you can create manually and do it. That is possible, but it is possible by manually. But in Stata, we can do both type of transformation in few commands. So that I am going to now show you. So let's go to the Stata. Okay, so I am deleting or saving this file in different names. So I'm going to use this same file to so that we can compare the results. So I am saving in this folder. So I'm saving two files. This is the with calculation and without calculation, because I will give you both the files. No. So this is the data. Okay, and in the data, I'm removing all the calculation part. So how to do in Stata? Let's see. Because in Stata is very good for doing all these calculations. Okay, so this is the simple data. And I'm closing this. EViews. In EViews, we have only one option of fixed effect that I already show you. And now let's go for the Stata. We have the Stata 17. Let me check. We installed Stata 17, but how to open it? Uh, so this is Stata 17. Let's try on this. First of all, we have to open the data, import CSV file, and file to import is day 56 within data. So we have IT sales advertisement in R&D. Yeah. Submit. So we have now the data, and I'm showing you the commands of applying fixed effect and random effect model. So we can apply the commands here. So first of all, you have to put xt set and I and T. So we have balance panel. And now I am going to put the command. So these are the commands we have to run. I just put it, copy and paste it here. Okay. So first of all, we have to go for this. Now here I am going to apply XT-reg because I am going to apply panel regression model. XT regression means panel regression. XC is for panel data. So XT-reg, this is the format. So in Y we have to write sales. In X1 we have the advertisement. In X2 we have RD. In X3 we are having the promoter holding. You can click here. The variable will come. And FE. FE means fixed effect. And which fixed effect? Within fixed effect. Now you can see that the software is giving you warning that promoters holding omitted because of collinearity. So why I put promoters holding is because to show you that whenever some variable is constant with time, this problem will come. So ideally you cannot include it. Okay, so by default, the software removed promoters holding. Now, and now you know that what is the meaning of 73, what is the meaning of 107, what is the meaning of 347. So, and you can see that there is a value which is row, and I will explain row in much detail. But as I told you that there are two types of variations, heterogeneity comes. One is the because of the individual effects, individual alpha, and one is the total variance. Okay. And if you want to see the effect, so we can give this command, estimate store fixed effect. So software will calculate the individual effect after this command. Right? Okay. So estimate store effect. Now we have to run some more commands. So let me try to show you that. Now I run two commands here, predict mu hat mu and effects. I'm calculating the effects, mu hat plus cons. And after these commands, go to data editor, and you can see the effects. So the effects of first company is 171, then -10, and 167, and 14. So the same effect which you have here. So just for showing you in the eViews, in eViews we apply sales, RD, AD, and opening as equation. Panel option is fixed. Okay. And go to fixed effect, random effects, cross section effects, 171, 10, 161, 14. So these values are coming in stata like this. So 14, 167, 10, and 171. So these are the individual effects which is calculated by the software. Now I hope you are very comfortable in that. So similarly, we can apply the between effect model. This is the within transformation model. And after that, we can apply. So in this command, so we apply, yeah, this. If I, rather than FE, if I click on BE, so now the transformation will be between fixed effect model. So in this, the software is not giving you anything, because for that, the value should be same for different cross sections. So that we will apply in that case when the variables are cross section invariant, then we apply between effect model. But here we are not having any variable which is same with cross section, so between model is not coming, and we apply this between effect rarely, so not getting the result. And if I remove this variable, let me check now. Yeah. So we are having the same 0.380 and minus 1.5, which we calculated in the Excel sheet. The same variable, we are getting this. But we apply between effect model very rarely. So I have less command on this. Most of the time we apply within fixed effect model. So after this example, you can understand that what is the transformation, what is the meaning of the transformation, and what kind of transformation we actually apply in fixed effect model. And after this transformation, now we can understand the random effect also. So my next session will be focuses on the random effect. So where I bring this information at the next level. So I hope you understand the between effect, within effect, and the transformation we are applying for calculating all these values. So regarding the within transformation, I think I have shown you each and everything. So that's it from today, for today. And give me a minute. If in case of any confusion, we can discuss on the discussion.